Hey guys, welcome back. We're going to go over the study guide for the circuit test we're going to be having. So looking at number one up here, we have three resistors. In physics, we would describe their relationship as being parallel to each other. So I want to put these into my chart. I know that the prefix little k is 1,000. So R1 is going to be 10,000. R2 is going to be 2,000, and R3 is going to be 1,000. And I also know that my total voltage is 10 volts. All right, so the next thing I'm going to do is I'm going to combine the resistors into one. And I know that in parallel, 1 over the resistance in parallel equals 1 over R1 plus 1 over R2 plus 1 over R3. So this ends up being 1 over R1 plus 1 over R2 plus 1 over R3. All right, so I'm going to put in my values. I have 1 over 10,000 ohms plus 1 over 2,000 ohms plus 1 over 1,000 ohms. Now I'm going to put this in my calculator. And I get 625. So that's going to go in my chart. So my R total or my R parallel is 625. All right, so I'm going to, I feel like it's not dark enough for you guys to see. Let me pause this first. All right, I turned the lights off and got some other lights so you can see both what I'm doing and what's up on the board. All right, so now that we have the total resistance and the total voltage, we're going to look at this equation that's derived from Ohm's law. And this is going to hold true for all ideal conductors. So I'm going to say that V total equals I total times R total. So that's for this row, because I have two things in this row. I'm going to get the one in the middle. And so if I want to get I total, I'm going to divide by R total. And that's going to be 10 volts divided by 625 ohms. And so I got 0.016 amperes. So capital A would be for amperes. All right, now, once you get to this point where you have everything you know and the totals, you have to remember ISVIP. So ISVIP tells us that current, which is what I is the same in series and voltage is the same in parallel. So if I look at what I have here, in our first case, these are all parallel. Each one of them has an independent path to this 10-volt battery. So they're all going to get to 10 volts. What's the disadvantage of this? You're going to run out of the battery sooner if you're hooking more things parallel. So that means I can put 10 here, 10 here, and 10 here. I'm going to put units up here so I don't have to put them down there. All right, so now I can get I1, I2, and I3. So V1 is going to be equal to I1 R1 So I1 is V1 over R1. So this is going to be 10 volts divided by 10,000 ohms. So 0.001. I'm going to switch colors to differentiate a little bit. All right, now I'm going to get I2. So I'm going to say that V2 is going to be equal to I2 R2. So I2 would be V2 over R2. This again is getting 10 volts, but now R2 is only 2,000. So this is giving me 0.005 amperes. Once you get two of them, there's two different ways to get the last one. So I know that all of the current's coming out, and I know that all of the current's going in. And I know that some's going this way, which would be I1. I know that some's going this way, which would be I2. And I know that some's going this way, which would be I3. I have to account for all of this charge. So the charge has to be conserved. So that means that this current plus that current equals the total. So I3 would be equal to I total minus I1 minus I2. So from our chart, I total is 0.06, I1 is 0.001, I2 is 0.005. So I get 0.01. Or I could say that V3 equals I3 times R3. So I3 is V3 over R3. So this is going to be 10 divided by 1,000. And that's also going to be 0.01. So if you have instances in your circuit where you're not doing any rounding at all, these two ways will get us exactly the same answer. If you do some rounding, then they might vary slightly. All right, on to the second one. Maybe. I thought I put the clicker in. All right, so this one has three in series with each other. So they share a path. This one's easier. So first thing, I'm going to put my resistances into my chart and my voltage. So my voltage is 9. Put my units up here. And R1 is going to be 23,000. R2 is going to be 10,000. R3 is going to be 25,000. All right, so what I want to do is I want to find the total resistance. Well, I know that in series, my R total is just the sum of my individual resistances. So this is going to give me 23,000 plus 10,000 plus 25,000. So that's going to be 48,000 plus 10,000, so 58,000. And I'm going to put that in my chart. All right, now I have two of the things in the total row. I should be able to get the last one, which is going to be I total. So I'm going to say that V total is equal to I total times R total. So I total is V total over R total. And I can see right off the bat that I'm going to have some rounding when I do this. So when I do the last one in the two different ways, I'm not necessarily going to get exactly the same thing. All right, so I got 1.55 times 10 to the negative fourth. So I'm going to call that 1.6 times 10 to the negative fourth. All right, now that I do this, I'm remembering ISVIP. I know that current's the same in series, voltage is the same in parallel. So looking at my circuit, these are all in series. Everything's in series. The battery's in series with the first resistor, the second resistor, and the third resistor. So if we trace our conventional current, our arrow does not split. There are no junctions. All of it has to go through each of the circuits. So that means that this 1.6 times 10 to the negative fourth can be rewritten for each one of them. Let's start at the bottom this time, just to mix it up a little bit. We'll do 3. So I'm going to say that V3 is going to be I3, R3. So this is going to be 1.6 times 10 to the negative fourth times 58,000. Sorry, times 25,000. That's why I normally do these like first thing in the morning and not in the afternoon. So after school, it's parent-teacher conferences, so I'm sticking around so I don't have to drive twice. I got 4. All right, I'm going to do V2, which is going to be I2, R2. This is going to be 1.6 times 10 to the negative fourth times 10,000. I got 1.6. All right, 2 ways to do this. First way, I started with 9 volts. I need to use all of that potential up when I go around any loop of my circuit. In this case, this circuit only has 1 loop. So I have positive 9 volts. This one loses 4 volts. This one loses 1.6 volts. So I started with 9 volts. I lost 4 volts. I'm losing 1.6 more volts. So it looks like I have 3.4 left. And I know this isn't going to be exact because we had some rounding in here. But I can do it with the equation derived from Ohm's law as well. So I have the 1.6 times 10 to the negative fourth times 23,000. And I got 3.68, so about 3.7. So they're close. When I did my rounding initially, it was 1.5 something, and I rounded up. So that would make sense that when I do these, I'm going to end up with more than 9 volts because it's a little bit more current than I thought there was. All right, the last type of problem like this we could do would be a combination. So that's going to have series components and parallel components. So again, I'm going to fill in my chart with what I know. I know that I start with 10 volts. R1 is 1,000. Remember that little K is 1,000. R2 is 680. R3 is 4,700. And R4 is 1,500. All right, so it's not as simple as we had it before to combine the resistors because I have some that are parallel and some that are in series. So if I look at my current coming out, here is I total coming out, here is I total going in. This has to be the same. I know that they're not all in series because some of it goes this way, which is I1, and some of it goes this way, which I would call I, 2, 3, 4. So since the same current goes through 2, 3, and 4, they're in series. So I'm going to combine them in series. And I would call the combination resistor that could take the place of what R2, R3, and R4 can do in a circuit, I would call that R2, 3, 4. That's going to be R2 plus R3 plus R4. So this is going to be 680 plus 4,700 plus 1,500. So I got 6,880. Where does this go in our chart? Nowhere. Because there's no line for what R2, 3, 4 is. But I simplified my circuit. And now I just have my 10 volt. And now it goes through R1 and goes back for one path. And now it goes through R2, 3, 4 back in one path. So now I can combine R1 and R2, 3, 4 and get my R total. So these two are in parallel because some of the current's going to go this way, some's going to go that way. The proportion that it goes depending on how strong the resistances are to each other. So for this, I'm going to say that our total is 1 over R1 plus 1 over R2, 3, 4. So this is 1 over 1,000 plus 1 over the equivalent, the one that could take the place of R2, R3, and R4 together. So I got 873. So what does this tell me? This tells me that I could have a circuit with a 10-volt battery and one single 873 ohm resistor, and it would behave exactly the same as this one would. All right, so now I have those, I can get my I total. So I know that V total equals I total times R total. I know that I total is V total over R total. And so I have 10 volts divided by 873 ohms. And I have 0.011 amperes. Now this did have some rounding in it because it was 0.01145, which is close to being rounded up to 0.012. So I wouldn't expect our last one to figure out. All right, now that I have this, I'm going to say, what do I know? I know that current's the same in series and voltage the same in parallel. So all of these are in series, they're going to get the same current. This one gets its own current, but it's in parallel with the battery. This 1 kilo ohm resistor gets all 10 volts. So let's find out what that one is. And I called that one R1. So my current should be V1 over R1. So this is going to be 10 volts divided by 1,000 ohms. 0.01. And that gets all 10. All right, so how will I find out how much current goes in the other path? Well, I know that my total current, my I total, has to be equal to I1 plus I2, 3, 4. So I total minus I1 is equal to our missing current that goes through 2, 3, and 4. So this is going to be 0.011 amperes minus 0.01 amperes. So that's going to be 0.001 amperes. Where does this go? Well, these are in series, so they all get it. All right, so now I can get what R2, R3, and R4 is. R2 voltage drop will be I2 times R2. So that's 0.001 amperes times 680 ohms. So that's 0.68. B3 is going to be 0.001 amperes times 4,700 ohms. So that's 4.7. And then the last one you should be able to get in two different ways. I feel like I'm going to be way off on this. One of them, I know that I had 10 volts here. And when I crossed that first resistor, R2, that was only 680, that I lost 0.68 volts. So now I have 9.32 volts. And I know when I cross this other resistor, the 4,4700 ohms, I lost 4.7 volts. So I'm going to take 9.32 minus 4.7. This is 4.62. Or, and I feel like this is going to be off by a lot, this is going to be equal to I4 R4. So 0.01 times 1500 is only going to be 1.5. So the last one varied a little bit on us. But I did do some rounding. All right, so we're going to move on. One of the things with current is it has to all be accounted for. It has to be conserved, very much like charge. So the amount going into a junction has to be equal to the amount coming out of a junction. So if I have 11 going into this point, I have to have 11 going out. Well, if I have 7 going out that way, that means I need to have 4 going out that way to account for it, so that all of it is accounted for. All right, so the same amount going in as coming out. We have 300 going out, and we have 30 going in and 120 going in. That's 150. So that means that I need to have another 150 going in, so I end up having 300 going out. So now I have 300 going in and 300 going out. All right, a hairdryer operates an internal resistance of 1,000 ohms at 120 volts. What is the current running through it? So we're assuming this is an ideal conductor. And it looks like it is 1.2 amperes. All right, adding resistors, compound resistors. The point of this is always to try to make it to be one path. And to get it to be one path, you should try to eliminate any parallel junctions. So I know that the current is either going down here and splitting or coming here and splitting. So I want to replace those two. And I'm going to replace them with one that is called R1, R2. And that's going to be equal to 1 over R1 plus 1 over R2. So R1 is 10, R2 is 10. So if I put 1 over 10 plus 1 over 10, I get 5. So that means I can redraw this as R3 and R12. So I made something that had parallel and series into something that only had series. So I can replace these with a resistor that will be the sum of the two resistances. So this is going to be 5 plus 10, or 15 ohms. Number 8, we just have 5 resistors in series. So I'm going to say that our total is going to be R1 plus R2 plus R3 plus R4 plus R5. So we're going to have 7 plus 7 plus 7 5 times. So the idea is that a 35 ohm resistor would do exactly the same thing. It would take the place of it and not change the circuit at all. All right, guys. Good luck on the test.